Hi, my name's Sean McCullough. I work at Groupon Engineering. Thanks for coming to my talk after your giant cheesesteak lunch. I would probably be in a food coma right now if I ate all that too. But I wanted to walk you through a project that we've just completed at Groupon, or completed about probably 6 months ago. We call the project I-tier for the interaction tier, and it's about how we broke up our monolithic Ruby on Rails app, and particularly focusing on the front-end layer of that. So the presentation is about how Groupon software stopped working, how we rewrote a part of it, and what went well and what didn't go that well through the process. The abstract might have kind of hinted that this talk was somehow about Node or JavaScript. Those are tangentially involved, but it's not really important to the core part of this talk, so sorry if that's what you came here for. So I'll start by kind of laying out the problems that we had. Groupon, if you've read any kind of tech news over the last 5 years, we're this really successful, hyper-growing company. We started actually as a small application called The Point, which was a kind of like a Kickstarter for charitable donations. So you and 5 of your friends would get together and be like, hey, if we all pitch in $20, we'll donate we'll donate some money to this charity, but only if all of us go in. We took that application code base, and since giving to charity doesn't make a lot of money, we turned it into something that would make us money, which is selling coupons. And that business model took off. Between 2008 through 2010, we grew by a massive amount. We went from launching in one market to pretty much every major city in the US. And we had a relatively simple product when we started out that was one deal for one city every day. As we began to grow, we made a bunch of acquisitions. So any tech startup, as soon as you launch a product in the US, there's going to be clones that spin up all around the world. And we knew that if we didn't either go into those markets ourselves or just acquire those clones, we'd never be able to get that market share back. I think like eBay has some serious competition in Europe. They'll never be able to really regain that territory. Yelp the same way in Europe. Like there's a parallel product. And at some point, I think those companies have actually bought out their European competitors like we do. So during this period of hypergrowth, we just bought these companies, rebranded their websites, but they maintained completely separate code bases with separate ops teams, separate marketing departments, everything like that. And then in the US, we added 3 new kind of product verticals to Groupon. So it became more than one deal a day. You'd have a gallery of deals. Some would be local, some would be things that we'd ship to you, some would be vouchers for vacations, some would actually involve booking a restaurant reservation or something like that. And some of these came through acquisitions that we kind of mainlined into our product, and some are things that we kind of spun up on our own. And then the tech stack itself kind of broadened. We added a bunch of additional features like personalized relevance rankings for deals. So we know that if you're a guy who lives in the city, you might not want like a spa or a waxing deal. We gave you the ability to search through the list of deals, and we created this awesome email deliverability system. So in the US, this is kind of what our infrastructure looked like, super simplified. But in reality, it was kind of more like this. We had 2 separate platforms. We had Rails and Nginx in the US, Apache and Java in Europe, 2 different database backends, different database schemas, all that kind of stuff. And throughout this period of time, smartphones really started taking off, and a lot of commerce started taking place on your smartphone. And Groupon's the kind of business that you're looking for something to do around you now. It's not like you want to go buy you're going to buy something and have it shipped to you later. Chances are you want lunch, and you want to open up your smartphone and be like, I want to get a good deal on lunch in Philadelphia right now. So it was a natural use case for us to move to mobile. So in order to facilitate that, since we had 2 different platforms, we created this REST API that worked on all of our platforms regardless of what the backend is. So we built out the contract through this REST API and implemented it all across the world. That allowed our mobile app to work all across the world. We shipped one Android app, one iOS app, one Windows Phone app, And they were able to geodetect themselves, talk to the right backend services, and then pretty much just work, which is awesome. The one downside is that we ended up getting kind of two facets to our code bases. So we would have a web and a mobile view of the same source of truth that existed in our database. But in reality, it was more like this. We would have two views for each layer, or for each one of the platforms that we had running across the world. And this really started slowing us down. We couldn't build the features that we wanted fast enough just even in our North American stack, because the code base was huge, and if we wanted to build out a feature for mobile and web, it would require doing double work. And we couldn't build out the features worldwide. If it required spinning up a new service or doing a database migration or something, that would be really difficult to orchestrate across all of our platforms at once. So we would have things that would only launch in the US. Our mobile apps would have all these regional conditionals in there, if I'm in Italy, only show this subset of features, or even in some parts of Europe, they would add features that wouldn't come out in the US. And because of this, we also, Groupon launched in 2008. It wasn't a particularly sexy-looking website in 2008, but it didn't age well at all. And we really wanted to get out of that, but we had a huge problem just coordinating this, look and feel change across our entire brand. So we came up with a plan to fix this, at least just for the web front end. We figured this would be the easiest thing to do. It hit a lot of the most pressing goals that we had. The site redesign was huge for us. Our product, VP of product and our designers were just getting fed up with working on this ugly website. And since we already had this REST API that worked for mobile worldwide, we felt like this would be a really good way for us to just kind of unify the presentation layer across all of our different properties all at once, since it worked pretty well for mobile. And working on merging together databases of users and orders and things like that is a lot more difficult, especially when you deal with privacy laws and how much information we need to silo in Europe as opposed to things that can't leave the US, credit card information. That was just going to take us a lot more time. So we also had some organizational goals that we had when we started this. We had all of these product teams working in one code base. So we'd have the deal page team, and we'd have the checkout team, we'd have the goods team, and the getaways team. And all of those teams kind of stepped on each other's territory a lot. And probably a failing of engineering management for a little while on our part was some of these teams would come in through acquisitions. They wouldn't really know how Groupon worked, how our code base worked, and they would be expected to immediately start committing and shipping their features into production. So we'd have flaky test suites. Our test suite took 2 hours to run if you ran it on a single machine. We had to distribute it out to 5 or 6 machines just to get it all working. And that made the development cycle just kind of grind to a halt. Our American platform was also built in such a way that we had hard-coded English strings all throughout it. So we had gone through almost a year-long effort just to internationalize our code base, and it failed. So we knew that whatever platform that we were about to move to needed to isolate teams so that they could build their own features without stepping on other teams. They could deploy those features whenever they need to. Our old app used to be deployed once a week. And it should allow for all these design changes, should be internationalized out of the box, and it should really have a small footprint. This is just the presentation layer. It should just serve HTML, CSS, and JavaScript. There should be no business logic baked in here. Push that all back down to the back end. So when you build out a feature, you can build it for mobile and web at the same time. So this is this is a way to visualize the way our old Monolith was. We just had this huge Rails app that was just broken into many different pieces, and this was kind of the goal, was that we'd somehow have Nginx route to all those different front ends, and then somehow also be able to talk to the MySQL cluster and to the different backend services. So with those abstract features in mind, we did a bake-off. Groupon has a huge engineering team now, and all of these technologies are used somewhere within our company at the time that we started to do this rollout. These kind of exercises are pretty futile. If you've ever tried to do one, they descend into religious arguments really quickly. we really needed to focus on like, the teams that were going to be building these applications, and just kind of the operational footprint of what it would be like to have this like rapidly changing web service. So I was a big advocate for using Node for these reasons. I think the biggest reason here is that front-end developers know JavaScript. And I think it's kind of wrong to ask people who are experts in HTML, CSS, and JavaScript to go learn another language to develop web applications. If they're not doing complicated business logic, they should be able to express all that stuff in JavaScript, and Node happens to be pretty much okay in every other capacity. NPM is pretty great too. If you've ever had a chance to use it, it's a great package manager, and it's a great way to resolve dependencies, but beyond that, it also allows people to use common libraries that they've been using on the front end for years on the back end. So things like underscore, if you want to use backbone models or some validation libraries, all that stuff, you can just pull it down and start using it in your app today. So we started with this page. This was the page, if you've never been to Groupon before, we try to get your email address so we can send you emails all the time. This was a good start for us because the APIs to just take your email address and send it to our database were simple to understand. They already existed. And it didn't look like the rest of the site. So we didn't have to worry about keeping it up to date with design changes or anything while we were going through this process. It was pretty standalone. But it did get a significant amount of traffic. We could probably get a sustained 40,000 requests per minute on this page during a busy day. So it wasn't something that it was completely throwaway effort. And this is some CoffeeScript, but this is like kind of a high-level design of what this page, like how to render this page, which is set a layout for the page. We need to fetch a list of divisions or like a list of cities just to kind of show you, we just geolocate your IP to the closest city, present you the name of that city, render the page. Like this is all any app at this layer should do is declare a layout, fetch some service calls, interpolate that data into a template, and render it. And we set up some boundaries inside of Groupon operationally about how these apps should work. So they're not allowed to have business logic. They're not allowed to have any other layer of persistence other than the REST API and memcached. The layout would be moved to a separate part of the application. I'll get a little bit more into that later. And also that there's going to be a shared asset bundle. So we did want to give teams a bit of autonomy, but we didn't want them to reinvent the wheel for every single page. We felt like if you're a developer on the deal page team and you move to the checkout team, you shouldn't be relearning how to do front-end development. It should all be pretty much standardized. So we built this application out. It took us a lot less time than we thought it was. There's a couple of growing pains that we hit when we started using Node, and I think this is something that you'll run into with any major infrastructure or platform change. The two things that I took away from this is you're going to learn things about your new platform that you didn't expect, and you come in optimizing for the problems of your own old platform, but your new platform will begin to deliver different issues. So for some reason, Node has this insane setting where it limits the outgoing HTTP connections to 5 per domain as a default, which for any application at any kind of scale is just stupid low. So we would be running load tests against this thing, and it would open up all the sockets, but it would just sit there waiting for the service calls to resolve. I actually just saw a tweet while I was banging my head against this problem that Substack, who's an eminent member in this community, was like, you should just always set this value to infinity. It's a stupid feature, and they should just turn it off. But it took us a little while to figure that out. And we also broke a lot of things in our infrastructure. Our old application was controlled by this ops team. They kind of understood how everything worked just within a bunch of tribal knowledge. So we set up this load test. We wanted to just make sure that if we threw a consistent amount of traffic at 1 or 2 node processes for a weekend, no memory leaks would come up, it wouldn't do weird things to the resources on the server or something like that. So me and the director of QA just set up this tiny little load test on Friday night, and we're like, see you on Monday. Within a couple of hours, we were getting paged. It ends up that somebody turned on SSL termination at our load balancer, which we thought was isolated to a test network, but that load balancer was actually being shared with production. With the amount of traffic that we were sending through the SSL termination spiked the CPU and took the entire site down. So this was actually a good kind of pain point for us to reassess our architecture a little bit and make sure that our test systems were completely isolated from our production systems. Stuff that I think was best practices, but these kind of changes really force you to re-examine every layer in detail. So we launched this thing out, and this is what our infrastructure kind of looked at right now. The subscribe flow was the app that I showed you. It just talks directly to the API. And then we have this separate config blob, which I will mention in a little bit. But we're starting to move pieces. Like we made this one hack just to get this one app up. And now we kind of realized like it was a simple application. It was kind of a partial implementation of what we needed to do. It didn't solve all of our problems, but it basically vetted that the premise we were working on, take slices of our web page, break them into a small app, and federate them out, was actually going to work out well for us. So we started with the second page, and this page is immediately a lot more complex. It caused us to solve a whole bunch of new problems. User authentication, we had to make a bunch of service calls and join some data together after the service calls came back. We had complicated routing. The first site was just a static route. This would be changing on a per city basis. So we had to do a little bit more magic with our routing rules. It had a lot more traffic. This is, at the time, was the default page whenever you hit Groupon.com, if you had ever come to Groupon.com before. And it needed to look like the rest of the website. So we couldn't let it drift with the look and feel. So this is where we start kind of building out a few pieces of architecture that allow us to support all those additional use cases. So this is kind of the end state that we get into now. And we're going to start drill into Grout, the config, and the way that we share layout across those applications. Grout is our switchboard for incoming requests regarding to iTier applications. So it allows us to use business logic to route an incoming web request to one of these many services. And as of right now, we have about 35 different backend services, all with really complicated URL routing rules. So for example, it could route the first route, which is like a showing the details of a deal, to the proper load balancer in our US data center. But if we hit for our German data center, if we wanted to go to the browse page, it would know how to route that into the German data center to that rollout of the browse page application. And it allowed us to do experiments between different URLs, different applications on the same URL. So we were able to do an A/B test between our old monolith and our new implementation. So during this rollout, we actually just re-implemented the same exact pages. We didn't change the features or anything like that. But we were able to collect data, put it through our entire data processing pipeline and say, if a user went to the subscribe page that was on this new platform, did they convert as well? Did they buy as many Groupon? Did something go wrong? And this was huge for us. It was a lot, like it let us kind of prove to all the naysayers, like this works and we're not breaking anything. Although during this period of time, we also found a bunch of cruft that we were able to kill because every once in a while we find this feature where it had like some obscure comment like only need this for like Starbucks Day or something like that. And, we cut out all this code and eventually somebody would come and complain and we'd put it back in as necessary. But it did allow us to remove a lot of like crufty old business logic from our applications. So this is what Grout would look like. This is currently the way it's set up in the US. We don't have anything completely rolled out there right now. These are all dark. But you can kind of get an idea. Like this is for groupon.co.uk. And you can see that it's actually staged to send 1% of traffic. It's a 2% experiment that it will send 1% of traffic back to the old monolith and 1% to the new layer. So we have a control in that routing bucket to make sure that we're not accidentally doing weird things with caching or something like that. And we can compare apples to apples in terms of how these new applications work compared to their old ones. GConfig is a way that we've tried to redo how we do configuration at Groupon. we have like 3 or 4 layers of configuration, from what service do you want to talk to what feature flags are on, to what assets do you want to pull in to create your asset bundle on the front end. This service is pretty novel because it allows us to write the config in development, push it up to UAT, and then promote it all the way through into production. And we can change the config on the fly. It just polls the server for every 5 minutes just to see if anything's changed. So it's pretty nice if we want to like roll out a feature flag or something like that. It's a updated GUI, and then it gets gradually rolled out to our entire cluster. And it's pretty nice. It's really just a service that merges JSON together. So you just write little JSON blobs and it pushes them out. But this has already lowered the operational complexity of our applications from needing to employ a release engineering team to go do a new release of config for our app and roll it out to the hundreds of app servers that we used to have, down to you can just add the flag and they just pick it up on the fly. And then the layout service is pretty interesting because this is the way that we solved the look and feel across the entire website. When you have 30 applications and they all need to look the same, like there's a few ways to solve it, and these are all things that different companies have done and different proposals we had inside of the company. I think companies like LinkedIn, they do like a Chrome service, so like you call into like a front-end application and then it routes out to the smaller applications. They just generate the internal HTML blob and send it back up. A lot of people still use ESIs, either at like the Apache level or at the Akamai or CDN level. But we decided to grab the templates from a service. This allowed us to have a team that was just focused on maintaining the look and feel of the website. And then it was just using a RESTful API that we did some versioning on. So teams can just grab whatever version of the layout that they want and dump it onto their page and then insert things inside. And using semantic versioning was really valuable. So if you want to get like you can either lock to a minor or to a patch level. Most teams should lock to a minor so they can kind of roll up with the changes. Some teams, like our SEO team, are very picky about how frequently we change the look and feel of the site on them, so they might want to be a little more conservative about how they roll out. But this also allows us to do site-wide changes of things. Like we do like holiday-based promotions, so like we'll do Valentine's Day and then Mother's Day and then St. Patrick's Day and stuff like that. If we went with a model where we embedded this layout into the application, that would require 33 deploys in order to roll out this new feature. But as far as anybody using the layout service is concerned, it's just not their problem, which is a nice division of labor. So this is what the layout service really gives us. It's just it's a partially rendered mustache template. It's really just another I-tier application, little node application that returns a mustache template that you will then render again inside of your other app. And it's pretty nice because with basically just changing a query string, we can go from that to this, which is our old look and feel to the new look and feel. So we built out all this infrastructure. We were able to get the browse page up and running using all these pieces. We got it up to about 60–70% of traffic, and we were like, all right, this is going to work. Let's do it. Let's figure out how to rewrite all the rest of the website. So we decided to do something that almost nobody does, or nobody who's gone through it would ever advise you to do, which is to stop everything that you're doing and rewrite everything all at once. But we had tried to do a redesign of Groupon right when I joined the company, and it failed because we couldn't cut over from the old look to the new look quickly enough. So we were supporting 2 platforms in parallel for a long time. And I think at this, we really just needed to dive in and get it done. So June of 2012, actually no, that should be 2013. We decided to move to I-tier by September 1st. So we gave ourselves a very small window to be like, everybody's going to stop what they're doing. You're going to learn this new platform. You're going to port your site over, and you've got a couple of months to get it done and launch to 100%. Our goal of September 1st was to have everybody launched, but not to be at 100%. And then we would give teams another month and a half to ramp up to 100%. But during even the time that I've been working on this project, Groupon grew quite a bit. We went from having, I think overall like 200 developers when I joined the company to I think now we're over 1,200 developers. We have developers in all over the world working on various parts of our platform. And we have at least just 150 front-end developers at the company, people whose jobs are solely owning the product for a certain page. So we rounded all of them up. We got them to coordinate through all their offices to get this done as quickly as possible. This is really difficult when you've got teams that are in Berlin coordinating with teams in Chennai, coordinating with teams in Palo Alto, so you don't sleep a lot during this whole process. But we were able to at least get the product team to commit to a feature freeze. So we weren't going to change the features. We were just going to roll out exactly what was there. To an end user, they should notice no difference between the old website and the new website. And it worked. This is a kind of graph that I built later in the pipeline, but you can kind of see it spiking up to 100%. And you can also see a lot of times where we had to roll back. It's definitely not a straight line going forward. You can especially see this one right up front. There's this huge lump and then cuts right back down. That's some page rolled out a feature with a huge bug, or business intelligence team was like, hey, you really ruined something, you got to turn that back off. But at least with the infrastructure that we built out, we had a lot of fine-grained control on what applications were taking what percentage of traffic, and we knew exactly how they were performing on all the key business metrics. So we weren't flying blind into this. And it was pretty awesome. Our pages got a lot faster. If I was speaking to a bunch of Node developers, I would give Node a lot of credit for it, but this is just the result of you kicking a bunch of cruft out of your code base. We more than halved our asset sizes. Just moving away from this monolithic application and the way that we were deploying Ruby on Rails with like mongrels on like REE 1.8, something like that. It was just the worst platform we could possibly have chosen to serve a high volume of web pages. And the new platform is just obviously suited to it. And this is also kind of an out-of-date graph, but they're getting, as we tweak our layout and push further optimizations into our back-end services, this goes down. But right now we know that our front-end layer is not the limiting factor in our performance, where it always has been in the company. Like our asset side, like for the longest time we were statically caching this page. So this graph is comparing a CDN cached page to a completely server-side rendered page, which you'd think that you wouldn't see this kind of huge drop, but somehow it did that. And then Groupon had an awesome reputation for going down every time that we launched something cool. So as I was kind of getting this project through the pipeline, before we even launched our first app, we ran a deal for Starbucks, which is like a $5 for a $10 gift card at Starbucks. I was just kind of sitting around like watching the show that day. Very quickly our site went down after that. Just so many pieces of our infrastructure kind of gummed up. We weren't able to support the ordering pipeline. The ordering pipeline then stopped feeding into another backend service, which caused all of our basic database schema to go, database cluster to go down. The first big spike in there is a repeat of that Starbucks deal that was actually like 25 or 30% bigger than the initial one. Nothing happened. Site stayed up the whole time. And then the big spike at the end is Black Friday and Cyber Monday. Again, nothing happened. We were all sitting in like a war room waiting for something to break, and nothing did. And this is just a way to kind of visualize how we've distributed things at Groupon. So each one of these colors is a different application, and you can see that we're able to resource and scale the hardware that we need for each one of these pages based off of the traffic patterns that they actually get. Before, we would have all this capacity when it was mainly just serving for 1 or 2 pages. So now we can just allocate the hardware for those pages, and then if we don't need things for like the subscription center or the unsubscribe page or something that gets relatively small amount of traffic every day, we can lower those resources. So I'll talk a little bit about what didn't work. Moving from a monolith to a distributed platform brings a lot of overhead with it. Testing got a lot harder. In our Rails app, we had this nice, maybe not nice, but thorough Cucumber suite that we had that would go through and validate all of the business features of our page. And when we moved away from having one application that we could kind of tweak the internals of while we were running the test suite, it got a lot harder to test our pages, especially site-wide. I think each one of the teams has a pretty good test suite for its individual page, but as of right now, we don't have like this really comprehensive automated end-to-end test suite that we'd like to have. And I think the tooling needs to catch up a lot. Just not only in Node, I think things like New Relic for Node have made great strides in the last couple of months, but when you have 30 applications as opposed to one, it's very difficult to composite all of that information that you get out of New Relic into pointing out, like, is my API going down, or is this a bad implementation of one app, or is this a library issue that one app just recently deployed it? There's a lot more data to collect, and it's a lot hard to get signal on like where things are going wrong. And there's a lot of operational overhead. Our ops team went from supporting a release engineering team who would promote a version to staging, test it for 3 days, and then roll it out to production kind of on their own. Like they had a really steady cadence. Now we have 30 plus teams that each deploy on their own with their own QA schedule and their own kind of release cadence where some do it twice a week, some do it once every other week. Chances are days before we do a big promotion, we're going to have 30 deploys in the span of an afternoon, and that's a lot to manage, especially if something goes wrong. It's hard to point a finger at any one particular application there. And then we had some really difficult culture problems when we made this shift. Now the ops is another good kind of culture problem to point to. Like our operations team really needed to change the way that they work. They needed to know, on-call rotations for a bunch more teams than they needed to care about before. But also the teams themselves needed to be responsible for this code. We had a group of developers who would commit to a code base, and then it was somebody else's problem when it got pushed into production. We put that problem back on the development teams, and I don't think all the teams were ready for that. We have some pretty nice internal tools at Groupon, but it still requires these front-end developers to have a little bit more kind of system skills than I think anybody expected them to have. I think the biggest problem are the last two issues that we now have these silos. So we have teams of 5 to 10 people who will build their front end out, and then on some teams like our goods business unit operates kind of independently. So they have a front end team, and then they have like various service teams in the back end. But now that we're out of the monolith, it's really hard to get eyes on their code. And I think we've seen just between different organizations that we have varying test coverage or code quality or standards about how you release things into production. We try to do things to make it hard for people to deploy things into production without letting us know, but there's nothing that actually stops teams from doing that. And we've had to kind of go find people who are silently deploying their app into production during the middle of peak traffic and be like, never do that again. But that was an issue that we never had before. And we also had like this big cultural shift that Groupon was like this really proud Ruby company based in Chicago. And half of my coworkers are at RailsConf right now. And I don't think that they were totally on board with moving away from something that they were comfortable with, moving away from a programming model that was kind of easy to comprehend, moving away from, I have all the data that I need all in one place. I can just go make a bunch of database calls and render this page. Isn't that easy? Come on, guys. Like, this is the right way to do it. I don't think we did, or like at least me personally didn't do a good enough job explaining why this separation of concerns was valuable, why keeping business logic out of your views is a really good thing to do. Ruby, especially Ruby on Rails, makes it far too easy to make a active record call from a template if you want to, and that should never happen. So this is kind of where we're at now, is working on building out the rest of this stuff. So a lot of our pages can be improved by using chunked transfer encoding. So we're working on prototyping that, especially for some of our pages that render huge gallery deals. Like we can just lazy load some of those things in. The more that I investigate this, the less I'm convinced that this might actually work out well for us, but it's an interesting thing to research. Ajax might work well. Just changing the product to show less data might work well. Making our services faster might be the best thing to do. Resiliency to outages, I think we got a lot of room by decoupling our front-end layer from having a hard dependency on a database. But we still kind of have a single point of failure in our API, and if we get extra Google crawling that day, or we run a huge promotion, and the whole backend goes down, the whole site still goes down. And I think that we could probably engineer a way out of that we can show our users something better than an error page. Distributed tracing is something that, since we moved away from having this monolith with New Relic just there for free, and you got to drill down into all different layers, like we need to build out our own solution for distributed tracing. And there's nothing that just gives you that for free, especially if you want a view of a Node system calling a Java Vertex system, calling a Ruby on Rails system, calling a MySQL database. That's varying levels of instrumentation that you need. We are looking into using Twitter Zipkin for this, but they have a lot of baked-in assumptions about it. It's kind of that old open source maxim where it's like, we released open source, but we basically just removed all the interesting business concerns out of it and left you a framework that, if you're not at Twitter, it's not that useful. Today, we're actually launching international. So I've been kind of running around watching to see when they actually flip the switch on that. But we have only launched this in the US. We'll be going country by country in Europe over the next 2 months to slowly roll that out. And then we'll be working on Latin America and Asia after that. So the goal is, by the end of the year, all of our front ends will be running the same code base, which will be a huge win for us. And then, just to make sure that we don't end up doing something like what I just accused Twitter of doing, is that we want to open source this stuff, but we want to make sure that we open source stuff that's meaningful. The first thing that came out, and I think it's gotten a lot of traction so far, is Testium, which is basically a Mocha-based testing framework that uses Selenium WebDriver, but it does it in a synchronous fashion in Node. The guy who wrote it, Sean Massa, who's on my team, really saw a huge need for this, and especially the way that you would have to do things with Node, like chains of callbacks and waiting for things to finish. He just wrote it in a synchronous way, so you can just do browser.visit this page. By the time that line's clear, you can just write on the next line your assertions, and it's a lot easier to reason about. So the summary of this is that we took our monolith, we separated it into a front end. We're working on doing the rest of our services that way too. Grout is a really cool tool that allowed us to kind of orchestrate this at a high level. And GConfig allowed us to change the way we did all of our configuration at Groupon so we can make changes on the fly. And then the layout service allowed us to coordinate the look and feel across all of these different applications. That's all I got. Thank you. Any questions? I'll start with you because I don't need a microphone. Yeah.
It looks like you have a lot of technologies in different stacks, kind of maybe just organically grew that way from various teams. Mm-hmm. Is that something you're looking to keep doing, like lots of heterogeneous code bases, or are you trying to move it all to one stack, like back to Rails? Or
no, I think we have at least 4 less technology platforms at Groupon right now. So you have kind of a base Java, a base Ruby on Rails, a Node, and then a Clojure one that's gaining popularity. We require all teams can pick technology that they want, but they have to go in front of the architecture committee to validate their choices and to prove that they know what they're doing. And they have to own that burden. And I think most teams will stay away from doing something new just because we're going to tell them that they're the ones who are getting paged. Like for the first 6 months, our ops team's not going to be there to support you. If you require a newer kernel or anything like that, it's on you to figure all that stuff out. that's usually enough of an uphill battle that teams will just pick something else.
Hi. I was just wondering what this looked like at the version control level. Did you go like trunk based, or like everything in one giant repo, or
Oh,
how
no.
did that?
So we have an internal GitHub Enterprise install, and teams just use that. So each team, like I'm on the core platform team. So each team, we have a Skeletor node project. Teams just fork that project and put their code on there. If we want teams to upgrade something, they just pull from our upstream and just merge it into their code base. But using GitHub internally is huge. I don't think we would have been able to pull this off if we had tried to use another tool.
How can you have both a site-wide consistency of look and feel and allow each app team to pick the version of the layout that they pull?
That is a good question. That is where there's still a lot of wrangling cats. So we have a product team that owns the layout. They have a product manager who, when they are looking to release a set of new features, it's not automatic. So we have each team go do integration testing against that new version. Once everybody says it's okay, they'll push that version into production dark. We have a way of bucketing you into that version with like a special developer cookie. We do manual testing. And once that's good, we use GConfig to push out the new version to all the apps. So for the most part, our patch releases are only going to be small fixes to things that shouldn't really impact user experience. The minor releases are a little bit more strenuous right now. But yeah, we do have some teams that, a couple weeks after we tell them to upgrade their app, they still haven't done it, and we just have to go bother them to upgrade.
So you had a 4-month code freeze to do this whole full effort. How much of it was done before the 4-month code freeze started?
So before the 4-month code freeze, my team had built the first application, built out the layout service, Grout. We tried to do a little bit of building out good testing utilities and stuff like that. But most teams started from scratch on the beginning of that 4-month deadline. We had example applications, so it wasn't really that hard to get up and running.
And so all of the business logic was moved out of Rails and into something else during this 4-month period, or?
I kind of glossed over this, but our Rails app was the web app and the API. They were just different facets of the same code base. So we left the business logic in that Rails app and just used the REST API to talk to it. All we did was just decouple the presentation layer. So like your web views didn't call databases anymore. They just called services for that stuff, and then they were taking care of everything from the REST response up to sending the HTML down to the browser.
I see. So then moving the API out of Rails into other things is an ongoing project?
That is an ongoing project. We're currently working on doing something like our routing layer for the API backend, so we can take v2 deals foo.json and do an A/B test between different backend services to move everything out. I think we're going to stay with having like a consistent API contract for right now, so you won't ever be talking to different services. We'll have a kind of single point of contact for all of them, and there'll be a service that does a lot of joins between the different data points, but yeah, that's the next process. This guy right behind you.
Just wondering if you could talk a little bit more about the tools you use to manage your layout services. Are you using custom tools or frameworks?
Yeah, everything's pretty much hand-built. We use Express.js. That's pretty much the only big off-the-shelf technology we use, and that's not really that big, just kind of as a routing layer. But we have our own asset compilation pipeline. We built our own template rendering engine. We built our own service clients. We built our own monitoring, instrumentation, logging, stuff like that. And we're trying to figure out how to open source it in a useful way. It's one all the way in the back over there.
A tweet I saw from earlier in the day says, there's no such thing as a successful rewrite. And I've seen this kind of sentiment before, that rewrites are bad. The world doesn't stand still while you pause and rewrite your app. So I'm curious what your take on that is, given that you froze your whole code base for 4 months?
Yeah, I think that really depends on how bad the problem is, right? Like we were stuck, like we couldn't get features out fast enough. Our VP of product was like hammering on engineers because they weren't shipping the features that he wanted tomorrow. So it took the hardest part of this whole thing was convincing him and the rest of the executive team, like, if you want this kind of cadence in the future, we just need to re-architect this stuff. The back-end service thing that we're doing is a lot hairier than like decoupling the front end. We really didn't do a ton of rewriting, complicated, hairy business logic. That stuff is a lot more cumbersome. Really, what we were doing is just kind of, forklifting our templates from one platform to another, and then just changing the data source on those templates. So it was a relatively small, constrained thing. But as of right now, we're still blocked on rolling out internationally because we're trying to launch all these apps at once, and one app has a bug that's holding up 30 other apps from launching into production. So, when we did it in the US, we did it app by app, which was a little bit easier. So I think it's a matter of how you slice and dice what you're actually rewriting, and also what kind of knowledge that you can have going into it that will prove that your rewrite is successful. I've seen a lot of teams just rewrite stuff in the cool new technology because nothing was wrong. And they didn't know if anything had actually, if it actually worked better than the old one. I would say Node is a cool new technology, but I think in the limited scope that we're using it, it's a perfect fit. But everything else that we did was pretty conservative and pretty boring from there on out. Any more questions? Cool. Thank you guys very much.